Thanks. Okay, when you're done with this half sheet here, when you've answered those questions, if you bring them up, just put them face down. Make sure your name's on them. And then there's a starter question, if you'd get that out and take a look at that. Once you're done with those three answers and have turned in that half sheet, there's the starter question. There's just an A and a B. Shouldn't be too bad. And then as far as graphing goes, and then there's a question about the distance formula and what's the definition of a circle, since you just got done reading that. Okay, so get those that starter question done with all four parts. That little writing assignment is an assignment, so make sure you do that. Okay. Are circles hard? They're pretty easy, aren't they? What's the center of this circle? The origin. Okay. And what's the radius? Radius is, so it's x squared plus y squared equals r squared, or x minus h quantity squared plus y minus k quantity squared equals r squared. So we take the square root of this, that's the radius. So from the center we go 2 units in all 4 directions, left, right, up, and down. And there we go. Now if you're going to get this right on a test, you would want to say the center is 0, 0, and that the radius is 2. Label that so people know you know what you're doing. What's the difference between A and B? Yeah, what's the center on this one? Okay, the center on this one is at 2, negative 1. Okay, notice that it's in parentheses, so it does the opposite of what you'd think it would do. It's going to move it in the x direction 2 units to the right. It's going to move it in the y direction 1 unit down. So we're at 2, negative 1, but the radius is still the same. So the radius here is also 2. So I'm going to go 2 units here, 2 units here, 2 units here, and 2 units here. And then we'll draw that circle. Didn't hit that one, so we'll make it nice and fat. And there we go. Good there? Okay, so graphing them isn't that difficult. Okay, but let's take a look at question D. What was the definition of a circle? You just looked at that a minute ago. What's the definition of a circle? Samantha?
A set of points that is a distance from a, was it a fixed point? A fixed point? A set of points in the XY plane that is a fixed distance from a fixed point.
Okay, so I'm going to write is a constant or is fixed. Okay, so it's a set of points whose distance from a fixed point is constant. Okay, so that fixed point is the center, and that set distance that's always the same, that's going to be the radius. So if you read the definition of a circle, the definition is a little bit on the confusing side. I mean, why don't they just say what it is, right? Okay, well, that's a nice mathematical definition. That fixed point is the center. So if you'll remember when we talked about circles, we said the only thing you need to know about a circle is just these two things. Where is it and how big is it? What's the center and what's the radius? So that fixed point is saying you've got to know where the center is, and that constant distance or that fixed distance, that's the radius. You know those two things, you've got it. Okay, and what was the distance formula? Can anybody tell me what the distance formula is? Big square root of? You could use that. x2 minus x1 quantity squared, and then y2 minus y1 quantity squared. Okay. If you go back and look at your notes, either from this class or maybe from 1010, I think we actually derived that formula. Okay. It's based on the Pythagorean theorem. Okay. So, kind of an ugly expression to use, but we've used the distance formula before. It's not that bad. Plug in the points, find the distance, you're all set to go. The definition of a circle sounds pretty awful, but in practice it's pretty easy to actually do that. Okay? Well, as it turns out, we've already covered circles, and circles are a very easy type of what's called a conic section. So we're going to talk about what conic sections are today, and then tomorrow we're going to introduce parabolas, but we're going to do parabolas a little bit different. They're not always going to be like y equals x squared or something like that. They're not always going to open up or down. Okay? So there are 4 conic sections, so I'd like you to write these down. There is a circle. A circle is a conic section. A parabola. An ellipse. And a hyperbola. Now they're called conic sections because of the way they're formed. Now on page 732, if you had a chance to read that, you saw these 2 cones that were set on top of each other and that sort of stuff. We're going to look at this a little bit differently so you can maybe get a sense for how these things work. So I'm going to turn the light off for just a second. If you're watching a cartoon, and on that cartoon there's a character, they go into a dark room and they turn on a flashlight. Let's say they're pointing toward the side. What shape do they show the light beams coming out of it? Okay, sometimes, but if you were looking at it from the side, what would it look like? Okay, it would look like a cone or kind of like a triangle, right? Okay, so it looks like a triangle when you look at it from the side in 2 dimensions. If I point it towards you, what does it look like? Looks like a circle, right? Okay. So if I turn this on, okay, there's the circle over against the wall. Okay, there's the circle if I point it right here. Okay, so if it looks like a triangle like this, what I've got here is coming out of this is basically a big cone of light. It starts small and gets big. Now if this was a really strong flashlight, we could have a wall 100 feet away and the light would show up there and it would be an even bigger circle. So it starts as a small circle of light and just gets bigger and bigger and bigger. So it kind of carves out a cone. Is everybody okay with that? Okay, now here's what a conic section is. If you take that cone of light that's coming out of this flashlight and you cut it, just make a big cross section like a whiteboard could do, then you get a conic section. So let me show you what a circle looks like. Okay, that is a circle. Okay, the cone is going straight into the board, okay, and it makes a circle. Now if I tilt it a little bit, if I tilt it like that, what shape is that? Okay, it's an oval or an ellipse. Okay, ellipse is just a fancy mathematical word for an oval, right? Okay, so that's an ellipse. If I tilt it some more, What does that look like? That looks like a parabola. And if I tilt it so, now notice the wall over there? I'm going to tilt it so it points over there. Okay? There's still an outline. This cone of light is still being sectioned. It's still being cut by the whiteboard. Okay? Is this a parabola? No. It's not a parabola. Okay? It's got a nice curve here, but look what happens right there. Look it out here. Well, it kind of disappears, but if this were a really bright light, it kind of straightens out. Because remember, you said that if we looked at this cone of light from the side, it would kind of look like a triangle, right? So if I do this, these sides get straighter and straighter and straighter. It's got this little curve in the middle, okay? But it gets straighter and straighter and straighter the further out you go. Now that's different from a parabola. A parabola continues to kind of curve around, okay? Not completely, not like an ellipse. It doesn't come around and connect again, and certainly not like a circle. But there's a circle. Okay, that cone of light is being sectioned perpendicular to that axis that's going right through here. I'm pointing this straight toward the board. Okay, if I tilt it a little bit off, like this, I get an oval, or an ellipse is the word that we're going to use. Tilt it a little bit more, I get a parabola, and tilt it so it only cuts this, parallel to that axis. Okay, right where I'm pointing it, then we get an ellipse, or sorry, a hyperbola. Okay, so those are the four shapes. Everybody good there? Okay. So now that you've kind of got a sense for how they're formed and what they look like, they do have tons of applications. If any of you have parents or brothers or sisters who work in anything dealing with electromagnetic waves and radio frequencies, different things like that, optics, lots of different things are applications for conic sections. Okay, so I want to underline a couple things. Each conic section has a definition that produces the shape. Okay, you're already familiar with one conic section. That's a circle. Okay, the definition is the set of points that are all equidistant from a fixed point. Okay, that equal distance is the radius. That fixed point is the center. Okay, it's the definition that produces the shape. Okay, there are similarities between the equations and the formulas that give each conic section. So they're gonna, if you just jumbled them all together, there are lots of similarities between them. So we can use stuff that we know about one to help figure stuff out about the other. Okay, and what's really important is that you're able to look at them and recognize which equation produces which conic section. Because some of them, I mean, they look very, very familiar. Okay. All the equations have squares in them, so these are all examples of perfect squares. Okay, that's just a constant times a perfect square, so that's still okay. Okay, and they may have linear functions, and most of them have constants in them. So linear functions are just plain old x and y terms, and then plain old numbers would be the constants. Okay, so here are the four conic sections. Okay, so we've got a parabola, a circle, an ellipse, and a hyperbola. Okay, so for convenience, I put every one of these so that the center or the vertex or the important point on it was at the origin. So here's a parabola. There's a parabola that opens to the side. And we're not bothered by the fact that that doesn't pass the vertical line test. These conic sections are not functions. Okay, circle's not a function. That didn't bother us when we were doing that. You can see an ellipse is not a function, and neither is a hyperbola. Okay. The only one that might be a function is a parabola that opens up or down. Okay, the other ones are not functions. Okay, no worries there. We're still going to study them, and we're still going to be able to make them pretty darn useful. So here's some examples of equations for parabolas. Y equals x squared. We're pretty familiar with that. X equals y squared. We don't see that very often. Okay, x squared plus y minus 4 equals 0. Notice it's got a squared term, a linear term with y, and then a constant. That's still going to produce a parabola. Okay, this one is y squared, or excuse me, y plus 1 quantity squared equals x minus 1. Okay, that's going to be a parabola when we graph it. And we're going to be able to figure out all the information that we need to draw a nice sketch and figure out all the questions that might be related to that. Here are some examples of circles. Okay, so the only thing that you saw here that we don't typically see is we normally don't see y squared, but we're going to be able to deal with that. Here's an x squared and a y squared equals 4. We already graphed that one earlier. Okay, we graphed this one earlier, and these two are in what we call general form. Okay, especially this one right here where we've set it equal to 0. Okay, so those are all going to produce a circle. So you'll notice either x or y was squared here. What about the squared variables here? Which ones were squared? X and y were squared. Okay, let's take a look at an ellipse. So it's either going to be oblong in the x direction, longer than in the x direction than it is the y, or longer in the y than it is the x. And take a look at these equations. Here's an equation for an ellipse. X squared plus 2y squared equals 4. Okay, the one right here was x squared plus y squared equals 4. By just putting that 2 in there, it goes from being a circle to being an ellipse. Okay? Again, one in general form where we've got everything kind of multiplied out, collected on one side. Same thing over here. Okay, so there's a circle. There's an ellipse. Take a look at this. That makes it a hyperbola. Okay? So if we had to look at these and we had to say, well, you know what? How could I tell which was which? Just by looking at it. Alex.
Ellipse is 2y, and it's at, and the hyperbola is still.
Okay, this is a 2y and it's got a plus between them. So this is a 1x squared and a 2y squared, and they're both positive. This is a 1x squared and a 2y squared. One's positive and one's negative. Okay, we've got a negative 2 in front of the y squared. Okay, that's good. What about the circle? How do you tell a circle from the two of these? What's that?
I want to say because there's the 2y as opposed to just y. So the 2 probably stretches it out.
2 probably stretches it out or does something like that in the y direction. That changes the y. Yep. Okay. Notice on each one of these I've got an x squared and a y squared, a minus 2x squared and a minus 2y squared. So it's not just that they're negative or positive. It's that these coefficients are exactly the same in every case. Here they're not the same, but they are the same sign. And here they're just different signs. Okay? How would you tell a parabola from any of the others? They're not two squared variables. There's only one variable that's squared. Okay? So one of the things that we're going to work on first is identifying which is which. And that's really easy to do when they're in general form. So general form is when they're written with everything on one side. Okay? So that's general form right there. That's general form right there. This one right here is in general form. So everything's on one side. It's set equal to 0. Okay? Ira, how are we doing there? I was just asking how you were doing. Good. What are you doing? Good. That's what we're doing. Oh, okay. Good. Okay. So if they're in general form, here's how you tell. If the equation has one squared variable, then it's what? Then it's a parabola. So parabolas are the easiest one to spot just by looking at the equation. If it's only got one squared variable, then it's got to be a parabola. Now this does depend, these next couple depend on it being in general form. They've got to be on the same side. Okay? If it has two squared variables, and they have the same sign and the same coefficient, then what would it be? Then it's going to be a circle. Okay? So if it's got one squared variable, we know for a fact what it is. If it's got two squared variables, then we have to look really closely. We've got to put everything on the same side, and we've got to look at it and say, okay, are they the same sign? Okay? And do they have the same coefficient? So let's take a look at the ones that were circles. They're on the same side. They have the same sign. They're both positive, and they're both positive ones. So we're good shape there. They're on the same side. They both have the same coefficient and the same sign. They both have negative 2's in front of them. Okay, so that makes it a circle. Okay, if they have the same sign and different coefficients, then it's a ellipse. And I like what Emily said about that right there. It's kind of like it probably stretches it in one direction or another, or stretches or shrinks it. Good way to think of it. Okay, and then parabolas are easy to spot and hyperbolas are easy to spot. The only thing you need is two squared variables, and they just have to have different signs. then it's a hyperbola. Okay? All right, so let's flip the page over, and I'm going to leave this one right here, and let's figure out which is which. So there are 6 of them here, and here's how we tell. If it's got only one squared variable, it's got to be a parabola. If it's got 2 squared variables, then we want to make sure that the squared terms are on the same side. And once they're on the same side, if they have exactly the same coefficient, it's a circle. If they have the same sign but different coefficients, then it's a ellipse. And if they have different signs, then we know it's a hyperbola. So which one's the easiest one to spot? Parabola. Let's run through here. Are there any parabolas here? C is a parabola because it's only got 1 squared variable, so that's a parabola. Any others? The one right below it. There's a squared variable with y. X is just a plain old x, so that one's a parabola also. Okay? So C and E are both parabolas. Okay, now if we look at the rest of them, 2 squared variables, 2 squared variables, 2 squared variables, and 2 squared variables. Okay? So they're going to be either a circle, an ellipse, or a hyperbola. Let's take a look at the first one. They're on the same side. What do you notice? This guy right here on A. Same sign and same coefficient. So what is this? That's a circle. Okay? They're on the same side. They have different signs. What is this? Hyperbola. Same signs, they're both positive here, but different coefficients, so this is an ellipse. Okay, now, what's the coefficient for the y, for the y squared, that is? Very good. Coefficient here is 1/4. What's the coefficient here? Negative 1/16. So the coefficient here is positive 1/4. Here it's negative 1/16. What do we really care about there as far as making a decision as to which conic section it is? Different signs. So what is it? Hyperbola. Okay? All right. Any questions? Okay. 11.2 is going to be about parabolas. Not using the same vocabulary or terminology for the most part as what you learned before. So make sure you come ready to do that tomorrow. If you didn't turn in your little half sheet of paper, make sure you do that. And bring your notes for tomorrow because we'll pick up right there.